let me start by something I refer to as famous triangles. Certain angles are different than others. Well, let me start with the isosceles right triangle. There is, up to similarity, there is just one. You draw a square and you chop it up in a half by the diagonal. Now, if the sides are 1 and 1, then the hypotenuse is, what's the hypotenuse of the isosceles right triangle with shorter sides 1?
Radical 2.
Thank you. And the angles are 90 and 45 and 45. And so if one side, if one side is A, say if it's the shorter side, then you can call the long one B, and then you're going to get A squared plus A squared is B squared. B squared is 2A squared. B is square root of 2 times A. But basically, just think of this and blow it up. 1 to A, multiply everything by A, right? And if the long side is given, well, how do you go from square root of A to A? By a division, right? So whenever I can, I avoid calling this x. I usually call, you have seen it on a video, I call this x and this is square root of 2x. But if this is x, this is going to be x over square root of 2, right? But basically, so the devil that is in the details is that in general, you can't have it both. Either the angles are nice and then the sides are terrible, or the sides are nice and the angles are terrible. These are the exceptions where you can actually know both the angles and the sides up to perfection because it's half of a square. There are certain symmetries. Most of the time when you're asked exact value, that means you cannot use approximations. And that means that with radicals, square root of 2 is the only option. Because as a decimal, square root of 2 never stops. And it doesn't even repeat. So if you try to write down something like square root of 2 as a decimal, you're never going to get the exact value. You can sit there till the end of times and write that one number and you wouldn't nail it. So whenever you see exact value, you have to use this and not 1.41 or whatever. And I don't know many digits. There's infinitely many and there is no repeating pattern. Okay, so that's probably the easiest one of the famous triangles. Okay, so the second one that's kind of famous is, well, I guess the regular, but the regular triangle is not that exciting. All three sides are equal and all three angles are equal to each other, therefore they are 60 degrees. What is the next? So this is the regular one. You know what is a fun and famous triangle is the semi-regular triangle. When you take the regular triangle, and I'm going to call this side 2, because the first thing we're going to do is we chop it apart. So this is 1. And just ignore half of it. Now this is going to be probably the most frequently seen triangle. This is called a semi-regular because it's not because it's almost regular, it's because half of a regular triangle, right? Can you figure out with the help of our good old friend Pythagoras what this height is, how long it is?
√3.
Very good. I was hoping if it's a wrong answer, then some people think that this is the hypotenuse, but you avoided that trap, right? So 2 squared equals 1 squared plus this squared, and then this is how we get square root of 3. Oh, and what about the angles? What are the angles, the 3 angles in this triangle here?
30, 60, 90. Oh, no.
Yeah,
90.
Yeah, and some people refer to it as a 30, 60, 90 triangle. That's the same as a semi-regular triangle. You're going to see a lot of this, but it's important for you to remember this is where it's coming from, because, and it took me a while to recognize this, that I think this has to do with congruences. Any right triangle in which the shortest side, or I don't even need to say, in which a side is half of the hypotenuse is the semi-regular triangle. Just simply for that fact that if you just double up and reflect this, now this side is the same as this, and now this is the same. So all three sides are the same, right? So any right triangle in which a side is half of the hypotenuse is the semi-regular triangle, is the 30, 60, 90, or semi-regular triangle. And if you have one, you need to know, so you need to know that it's the shorter side. So it's just the shortest side that's opposite the 30 degree, this is half of, because we're taking half of the. So you need to understand that triangle pretty well, because it pops up in all kinds of places. It quite often happens that this here is half of that. And if there is a right angle, but you have to be careful that the hypotenuse is double. That's a semi-regular triangle, so because of its origin story. And then they are all similar to each other. So if this is x, this is square root of 3 times x, and this is 2x. And if this is y, then I would start with this y over 2, and I would use the Pythagorean theorem. It's probably square root of 3 over 4y. Square root of 3 over 2. Yeah, 1 squared minus a quarter. It's 3/4, but the whole 3/4 is under the square root, so it's square root of 3 over 2. You just use the Pythagorean theorem to figure it out. Okay? So this one is an important one, and you're going to see a great deal of it. Any questions? Okay, so I should stop because this is the, I guess instead of famous, we could say algebraically approachable, because there are symmetries in the Pythagorean theorem, which means we can actually find the exact value. Most triangles, we can just put a ruler there and measure, and we get an approximation. It's kind of a turn-off. Now, not as romantic as these famous triangles, but ever since I've been doing quadriona puzzles, I think there is another triangle I should show you. I gave it a name because it's not famous officially, not yet. Do you ever play dominoes? You know what a domino piece looks like? Basically, when you put two squares next to each other. Now, when you put two squares next to each other, then again, one side is going to be double of the other, but not the hypotenuse, right? You have this 1, 2. I call this the domino triangle, and it pops up a lot ever since I'm dealing with Catriona Schiller's puzzles. So it doesn't have an official name, but I just call it the domino triangle. Can you, if this is 1 and this is 2, and again, you see one side is double the other, but the hypotenuse is not playing. How long is the hypotenuse?
Five
Square root of 5.
or square, yeah.
Yeah, for 5, it's not even a triangle because 1 plus 2 is not in, is too small. So I guess it's not famous in the sense that this has disgusting angles as well. Some yucky numbers.